Okay, you're going to be asked about the number of turning points that a polynomial graph has, and that's, as it states here, places where the graph changes directions, and that's going to occur at the top of a hill or at the bottom of the valley. It's just the way I refer to it. Now, your formula that you're going to use that will help you determine turning points is going to be at most n minus 1. Now, the words at most is very important because it's not always exactly n minus 1. Okay, it's just that's the most it can have. Now, if you remember, they're using the letter n to represent the degree of the polynomial. If you remember, that's just simply the largest exponent with these polynomials. So if your largest exponent's a 3, you would say 3 minus 1, so therefore you would have at most 2, okay? So we'll be using that in just a little bit when you're asked about turning points. Now, something else that you're going to be asked about is increasing and decreasing intervals, okay? So you'll need to, of course, write this down. Now, it's very important that you notice that it states here from left to right. You always have to make sure that you go in that particular order, okay? So when you're looking at your graph from the left to the right, if the graph is upward, then that would be considered increasing. If the graph is downward, then it is decreasing. And then when you're describing where these intervals are, you need to make sure that you use your x values, okay? Now, before we actually work an exact problem, I just want to give you a quick little idea of what that's referring to. So let's say that this is our graph. And as I said, from left to right. So if you start tracing your graph from the left side around to the right side, as it states, if you go up, then it's increasing, down would be decreasing. So like if I start tracing this part right here, that's going to be a part that's considered increasing because I'm going up a hill, okay? So I would increase on this portion here that I've got highlighted, but the increasing is going to stop right there because then what happens on the other side, like from here to here, I would be going down a hill. I would be going downward, so that's going to have to be decreasing, and it's going to decrease until I get to there. But then I pick back up, and I'm going to be going back up a hill, okay? So when you look at it, like I said, from left side to right side, this part increases, then it decreases, and then it increases, okay? That's what we're going to be looking for. Okay, first problem that we're going to look at, and we're going to use our calculator to help us out with this. You are asked to determine in behavior turning points increasing and decreasing, okay? So we'll have to use our calculator to help us with the increasing and decreasing. So let's talk about in behavior. Okay, first of all, n, which is your degree, is going to be your largest exponent, which is 3. And your leading coefficient is going to be, of course, the number in front, which also is a 3. So you remember, you look at this as being odd or even. You look at this as being either positive or negative. So if you have the combination of odd and positive, that means that your left side's going to go down and your right side is going to go up, okay? Now, number of turning points. So what you would do there is you would say at most. Make sure you write those words. So it's at most n minus 1. So that would be 3 minus 1, which is 2. So you would state that you have at most 2 turning points. Okay? Now, on the increasing and decreasing, you're going to have to put this in your calculator. So just type it in your y equals. And this is what you're going to see. Now, I'm going to change my window just a little bit here. Like, I just kind of need to see this middle portion in here just a little bit better. So I'm just going to use the go to Window, and I'm going to chop off some of my x-axis. And then also some of my y-axis. Let's see if yeah, that'll work good. Okay, so like I said, you have to look at it from the left side to the right side, okay? Now, if you start tracing it, and I'm just going to draw on my screen here. If I start tracing, see from here up to the top, that's going to increase. And then it's going to come down, which is going to be decrease, and it's going to come back up, which is increasing, okay? But the catch is I have to know this x value at the top of the hill and the x value at the bottom of the hill, okay? So we've got to do exactly what we did just a few minutes ago. No, I'm sorry, we haven't done that yet. I'm going to have to show you how to find those numbers. Okay, so let's start over with that. You didn't do it a while ago. I want you to hit your second function and then trace. And you're going to choose maximum. Now, the reason why we're choosing maximum is because I'm at the top of the hill. Anytime that you're at the top of a hill, then that's going to be a max. Now, at the bottom right here, it says left bound. So put your cursor on the left side. Hit enter. And then you notice your question is right. So we'll move it around to the right side. Enter. And then back up here to the top. Enter. All right, so all I need, remember, is just my x value. So I'm just going to jot this down on a piece of paper to the side, and then I'll write it down for you in just a second. All right, so my x value there is going to be negative 0.3. Okay, 1 decimal place is fine. Okay, then we need to do the same thing over here and go back to that same menu, but this time you're going to choose minimum because it's down at the bottom. Okay, so I'm going to choose minimum, but I'm going to put it to the left side of it, enter, and then move it around to the right side, enter, and then guess. All right, so my x value there is a positive 0.3. Okay, so what you might want to do, and like I said, this is just kind of an option if you want to. I'm just going to sketch my graph off. Like I'm not even going to put an x and a y axis, okay? It comes up, dips down, and then it goes back up, okay? This is what your graph is doing. Now we found right here, we found this to be negative 0.3, and we found this to be positive 0.3. I'm not even writing down my whole ordered pair because when I do increasing and decreasing, remember, I only want the x's, okay? So where is my graph increasing? So let's start there. Okay, so if I start tracing this first part from here up to here, I'm going up a hill. So going up a hill is going to be increasing. Now this is the left side. So the left side is negative infinity. So you're going to go negative infinity to the negative 0.3. Okay. Now typically you write these things with interval notation. This textbook doesn't do that. So I'm just writing it the same way you'll see, your answer. Okay, now, once you leave this point, this middle part is decreasing. So you're going to decrease from here to here. So that'll be the negative 0.3 to the positive 0.3. Okay, so now we've made it to here. And then this last part is going to end up being increasing again. So over here, we'll just put a comma. And it's going to start at the 0.3, and then it goes to the right, so that means it's going to go to positive infinity. okay? All right, one more to look at real quick. And let's do our end behavior first. All right, so n is 3, because that's my exponent. The leading coefficient's the 1/2. So again, this is odd, this is positive, so it happens to be the same as that last one. The left end's going to be down and the right side's going to be up. Now, when you do your turning points, you remember it's at most n minus 1. So again, n is 3, minus 1 is 2. So it's at most 2 turning points, okay? Now, let's put this one in the calculator. And actually, I don't have this one typed in yet. So let me clear that one out. So I've got 1/2 x cubed. So let's just do 0.5 x to the 3rd power. And I'm going to go back to Zoom 6 because I changed my window up a while ago. Okay. So, again, I'm just going to do a rough sketch. Of course, it comes up through the origin here and goes on up. So let me come back over here. And here's what my graph is doing. Now, sometimes you get confused about this middle part right here because you think, well, there's a hill. Well, a hill means that it has to actually curve and start going back down on the other side. This is actually not a hill, okay? So when it comes to your increasing and decreasing, once you start tracing this graph, it's actually doing the same thing the entire time. From left side to right side, you're going uphill the entire time. So you would say that this graph increases from negative infinity to positive infinity. So you don't always have to have increasing and decreasing both on your graph.